Hello everyone, so in this video we are going to solve a question of LeetCode, that is furthest building you can reach. This is 1642nd question on LeetCode and this comes under medium category. Alright, so let's start with the problem statement. You are given an integer array heights representing the heights of the buildings, some bricks and some ladders. So basically in this question we have given an array of integers and two values, that is number of bricks and number of ladders. Okay, and you start your journey from building 0 and move to the next building by possibly using bricks or ladders. So we have to start from 0th building. So basically the counting of building starts from 0. It is not 1, it is 0. Okay, so the building 0, building 1, building 2, building 3, so on. Okay, and we have given two conditions while moving from building I to building I plus 1. Okay, like moving from current building to next building. If the current building, like the height of the current building, the first condition is the height of the current building is greater than or equal to the next building. Like if the height of the current building is greater or less than or greater or equal to the next building, it means the height of the next building is less than the current building. Like in the first example, the building 0 and building 1, the height of 0th building is greater than the height of 1th building. So we don't need to do any jump here. Okay, we will just drop it here. Okay, so we don't need any jump or ladder in this case, or we can say we need a jump but we are not using any brick or a ladder to climb, because we don't need to climb here, we just need to go down. Okay, so we don't need a brick or ladder in this case, so this value will not be changed in this case. Okay, now let's see the second case. In the second case we have if the current building height is less than the next building's height. Okay, if the height of the current building, let's say here the height of this building is less than the height of the next building, then definitely we need to climb this building somehow. So there are two possibilities, or we can say two ways to climb this building. The first one is through ladder and second one is through the arrangement of the bricks. Okay, so whenever the height of the current building is less than the next building, or we can say the height of the next building is greater than the current building, then we will be using brick or ladder. Okay, now let's see the conditions for using brick and ladder. Okay, so whenever we use one ladder, so it can climb to any number of height. Okay, there is no limit to the height which a ladder can be climbed, or we can say it can be climbed to the maximum height it is possible in this case. Okay, and the bricks, so the number of bricks used, like one ladder can be climbed to infinity, or we can say not infinity, till the maximum height this case is having. And in the case of brick, the height of the next one minus the height of the current one. Okay, like the height of the maximum minus the minimum one, or we can say the height of the greater minus lesser one is equal to the number of bricks we will be using to climb the building. So we will be subtracting those values and arranging in a way that it is optimally arranged. Okay, so these are the two conditions we need to check in this case, and we need to return the furthest building index you can reach if you use the given ladder and bricks optimally. So we need to somehow use bricks and given ladder optimally such that we reach the farthest building. Okay, so whenever these kind of questions comes, so the farthest or maximum, so these the first approach comes to our mind is greedy approach. Somehow we can get the maximum value. These are some of the greedy approach we do. So let's try to do this question through greedy approach. Okay, so let's create a heap here. Okay, so we will be using a heap in this question, and let me just compress the page. Yeah, so we will be using a greedy approach here. Now the height of the first building is 4 and the height of the second building is 2. So we don't need any a ladder or brick in this case, because it is easy to climb to the next building without using any brick or ladder. So in this case we don't need any brick or ladder. Okay, now let's see for the next condition. Now next we have 2 to 7. Since the height of the next building is greater than the current building, we need to climb this somehow. So to climb this building somehow, we will be needing a ladder or some bricks. So let's say we have used, because the number of bricks which we will be needing is 7 minus 2. Okay, that will be equal to 5. So we already have 5 bricks in this case. So let's use 5 bricks here. Okay, now the remaining bricks is equal to 0. Okay, and now let's try to climb to the next building. Yes, it's possible because it is less than the height of the current building. Now let's see for next condition. Here the height is 9 and the previous one is 6. So we will be needing 3 bricks here. Okay, we don't have any bricks remaining, so we'll be using a ladder in this case. Okay, so we have used a ladder and the remaining ladder is 0, and we are here right now. Okay, when we are here right now, so to climb to the next building, we will be needing a ladder or some bricks, but we do not have any bricks or ladder here because this all is 0. So what we will do, we will be returning this index because we cannot climb to any more building. So the index of this building is 0, 1, 2, 3 and 4. This is the fourth. So we will be returning 4 in this case. Okay, I hope the example is clear to you. So let's see how can we approach this question. So to approach this question, we will be using greedy approach, and through greedy approach we will be using a min heap. So since we were using min heap, because we need like to solve this question optimally, what we will be doing is we need minimum ladder. Okay, so what we will do, like let's think about this. Like whenever we will be using a ladder, we can climb to the maximum height. So why not to reserve this ladder for the maximum height? So let's try to occupy the bricks by smaller values first. That's why we are using mini here. Okay, so we will be just occupying the bricks with minimum values, and at the end we will be getting the greater value, so that value will be used by ladder. Okay, I hope you are able to understand this. So let's quickly create a mini heap here. Let's say this is our min heap, and what we can do is, rather than using a min heap, we can use max heap and converting the positive value into negative value. Okay, so this will automatically be converted into min heap. Okay, to understand it better, let's take an example. Let's say we have few values 1, 2 and 3, and when we will find the values in the min heap, so the minimum value is 1. Okay, now if we want to convert this into max heap, so how can we get this value through max heap? Just think about this, pause the video and think about this. Okay, so to get the minimum value, or we can say this value from the max heap, what we will do, we will just convert this value into the negative value. So it will convert to -1, it will be -2, and this will be -3. So now this is the maximum value, but actually in the min heap this is the minimum value. So what we will do, when we will store these value into our max heap, automatically this topmost value will be written because this is the maximum value in the min heap. Okay, and this we will be returning from here, and the actual value is basically the absolute value of this one. Okay, so I hope you are able to understand this, how we are converting min heap into max heap. Okay, so let's quickly see for this example. Okay, so let me just clear this. Yeah, so we will be using a max heap here. Now let's start the iteration. So let's see. So we will be basically taking the subtraction of the height of this building minus this building. So the height of this building is 2 and this building is 4. So the answer is 2 minus 4 is equal to -2. Since it is negative, then definitely the height of the next building is less than the height of the current building. So we won't be taking this value. So let's see for the next building. For the next building we have 2 and 7. Okay, so the subtraction of both the values is 5. Since it is positive, we will be storing this value into our max heap. So let's store the negative value, as we have seen in that example, that one we will be storing as -1. Okay, so here we will be storing 5 as -5. Okay, now we need to check is, like, we need to reserve some values for the ladder. So let's reserve all the maximum values. Like, maximum value will always be at the bottom of the max heap, so we will be reserving these ladder number of values. Okay, the total number of ladders will be reserved here. So whenever the value of this max heap will greater than the number of letters, then we will start popping out from here. So until this is under this range or is equal to the number of letters, we won't be doing anything here. Okay, so now let's move to the next building. This is 6 and this is 7, so this would be -1. We don't have to do anything in this. Let's move to the next building. Now here we have 6 and 9. Okay, so 9 minus 6 is 3. Since this is positive, let's push into our priority queue. Okay, so this would be -3. Now the size of this max heap is greater than the number of ladder. Number of ladder is 1 and size is 2. So what we will do, we will just pop out this value. Okay, so after popping out this value, what we will do, we will just add this into our bricks. Since the values are negative, okay, actually the values are positive, but we have stored as negative, so we will just add into this. So basically we are just subtracting the 3 from here, so this will become 2 now. Okay, now let's move to the next building. This has become, let me make it 2. Yeah, it's 2 now. Now let's move to the next building. Now the next building is, this is 14 and this is 9. So 14 minus 9 is 5. Okay, so let's push 5 into our priority queue. So when we pushed -5 here, again the size is greater than the number of letters, so we will just pop out this from here. So this will be subtracted from the number of bricks. Now this bricks will become -3. Okay, when this become -3 and the value of bricks is negative, so whenever the value of bricks becomes positive to negative, then definitely we have used a ladder at that time. Okay, so when we have used the ladders, so this will become 0 and we have completed the whole iteration, because we don't have any more ladder or bricks to go beyond, and this is negative, so we will just return the index of current I. So we are currently at this point, I is here. Okay, so we will returning the index of this one. So 0, 1, 2, 3 and 4. This is 4. So we will returning 4 from here. Okay, I hope the approach is clear to you. Let's quickly code it up. Yeah, so let me just zoom this. Yeah. Okay, so let's take a priority queue here. Priority queue of integers q, and let's run a for loop. For int I is equal to 0, I should be less than bricks heights dot size -1 and I plus plus. Okay, now let's take an integer int h. This will be storing the size of the building. Okay, like height of the building, between the difference between the both the buildings. Okay, so heights I plus 1 minus heights I. Okay, now let's check if h is greater than 0. If it is greater than the 0, then definitely the height of the next building is greater, so we need to climb this using brick or ladder. Okay, so what we will do, we will just push this into our priority queue. So q dot push -h. Okay, I have already explained why we are taking -h here in the example. Okay, so now let's check if q dot size. Okay, if q dot size is greater than the number of ladders, if it is greater than number of ladders, then what we will do, we will just subtract those number of ladders, those number of like bricks from the bricks. Okay, so let's bricks plus equal to, why we are adding here, because we have already taken the negative value here. Okay, so bricks plus equal to q dot top. Okay, now let's just pop it out from here. So q dot pop, and let's check if it is bricks is less than 0. In this case, what we will do, we will just return I from here, else return, like if this iteration is completed, then what we will do, it means we have reached till the last building. If we have reached till the last building, let's just return the last index. So return heights dot size -1. Okay, I hope this should work fine. Let's just run it. Yeah, it's working fine. Let's just submit it. Yeah, it's working fine. So let's calculate the time and space complexity of a solution. So the time complexity of our solution is big O of n log of n, because the priority queue do internal sorting. So this will be around n log of n, and space complexity is big O of n, because at max, or in the worst case, this priority queue will be storing n values. Okay, so n is basically the number of letters, we can say, in this case. Okay, so I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.